Hey, so here's a recording. I want to just walk through what it looks like to filter GC-Net transmissions in the case of NEAM. I just plotted the transmitted data. These come from VSL and VDAT. This is the old GC-Net station where apparently the barometer isn't working at all. All the data are nans. I'm just gonna go with that for right now and look next at the temperatures. I actually, here is a filtering that I just commented out. I'm gonna run this without that filter, and we can see some transmission outliers. And so by applying this simple filter, adjuster, it's called, and I pass it temperature air 1 and 2, a time range from the 1st of June to 2021 to the 1st of April. It's a max filter, and anything above 2 for those two variables is going to be set to nan. I'll run that now, and we can see them go away. And this lowest plot is the difference of air temperatures 2 and 1, and it's looking suspicious starting kind of about here. And when this temperature difference goes positive, it's a temperature inversion. That is, the air aloft is warmer than the air below. This is common on ice sheets and glaciers, but then it goes, I can see kind of this positive trend here, and then it becomes erratic. And my expectation is that the lower temperature sensor is getting buried, or it's broken. Anyway, these data, they're relatively few. For the sake of the Harmony data assimilation, what can I do here? One of the things I can do is, well, I can discard temperature 1, and what this code will do, it actually just averages temperatures 1 and 2, and that goes for the Kara Harmony data assimilation. I I could guess that that's okay. I'm not that confident about it. I can see here, for example, just that temperature 2 is colder in these cases. Um, well, no, I think these dots are on top of each other. Anyway, there's something going wrong here. And to be conservative, I'm going to set these guys to nan. And so I have a filter for that here somewhere. I don't use it that often. Um, nanvar, it's called. So I copy this from another site. Um, and okay, for until the 1st of April, nan this var, we're going to nan out TA1 and 2. I'm going to do that starting on the, I'll start with the 1st of October. So 10-1, and instrument out, actually my comment is going to be instrument burial, BURIAL, question mark. I'm not, 100% sure about that. That's what it looks like. If I set these right, I run this, and I'm just chopping away that suspicious data. I want to, I'd like to make note of that. And one of the ways I'm doing this is, and I need to follow back about this, is to put in an exclamation point. And any of the comments that have this, I would say deserves more attention, and even the question marks deserve more attention. I think that's good enough for now. And as we go back in what we're calling the QC step 2, That is when we get transmissions or data logger data, rather, from the field, we can have another look basically by turning off the filters, plot the data, and see if we need the filters anymore. So that's a step that's coming in the future. But right now I need to deliver data in the next 6 days. So with a bit of time pressure, I'm being conservative. Maybe I should take a little bit more off because it's because of this trend. I don't like that trend. I'm being extra conservative, and I'm gonna discard 10 more days of data. Maybe that's a bit much. Let me run that, and that's what that looks like. Um, I think that's, it's being conservative. And again, we'll come back and look at this. The other thing I'm doing, so I'm calling this batch one. That's pressure and temperature. Those are the most important for Kara data assimilation, the pressure, the temperature. These other variables that you're going to see when I set the diagnostic plot or the batch to 0, we're going to see relative humidity, wind speed 1, direction, and I am now seeing more suspicious. So look at this. Relative humidity 1 is maybe this is again there's burial happening. Again, it's starting a little bit before October 1st, so I think I was right about that. And yeah, instrument 1 is being buried. Why is wind speed 1 still working, but wind speed 2 isn't? That suggests that, yeah, there's something. Yeah, no. Wind speed 1 is still working. Wind speed 2, it's like it's frozen. So this is quite interesting. Uh, but from what I can see here at NEAM, I'm going to apply the same filter to RH1, that is throwing out data, RH2, again from the 20th of September. I run this, it's not happy because there isn't a variable called HR2, it's RH2. Run that. I'm going to increase this so you can actually see. It's still not happy because RH1. Run that. It's tossing those data. I, you can see there's something wrong with the wind speeds. These are called VW1 and 2. What have we got here? VW1, velocity 1 and 2. It looks to me like velocity 2 might be okay from the 1st of November. Yeah, I think that's fair. So I'm going to say 11.1, and everything after that gets thrown out. And I want to apply a max filter to these guys. Let's see. I don't know what's the fastest way to do this. If I say max filter, and the max value that I'm going to accept, let's go with 14 meters per second right now. And I'm just going to run that and see what I get. Oh, well, the time range isn't good. So let's go from the 1st, or the 1st of June. Okay. Yeah, I still have this one outlier. See, if I make this a little bit higher, I don't think that's going to do much. No. 16 meters per second. Eventually, we're going to start to see some of these real outliers. There they are. So I'm going to go back to what it was working before. I have just one outlier that I think is an outlier. That's between the September and October. I'll go ahead and get that guy in there. The wind speeds are not directly used by the assimilation, actually. So I'm overachieving here a little bit, but the September and October, so that would be 9/1/2021 to 10.1, and I can lower that to say 12.5 as the maximum acceptable value. That dot should go away. Bye-bye. Okay, and finally for this batch, it's it's the same kind of issues. And again, I believe that the wind speeds it's as if they're swapped, but now I see the velocity of 2 is a little bit higher. So okay, they're not swapped, but there's something fishy about well, the fishy thing is that wind direction 1 is still operating, but 2 is fixed. Okay, it's frozen. This station's getting buried. I'm gonna nan the directions out as well. So that's called wind deer 2, wind deer 1, and I'm gonna nan them from 10.1 to 22.4.1, nan var. Let's see what this looks like. Run this. Yeah, that was too much, perhaps. 11.1 from November 1st. Seems like those may be useful. I've got the exclamation point, I've got the question mark. I'll proceed to this next step, which is to actually write out all of the variables. So I'm going to turn off my diagnostic plot, run that, and now you'll see all parameters for this site. Pressure's out. We've got issues with the data, but these appear to be more useful data. For direction, this looks to me suspicious, right? Again, because you don't have any values like this until it starts getting buried. So I'll just go back up and make that more conservative on direction. Instead of from November 1st, I'll go from, I don't know, the 15th of October on direction. And there I go. I don't know, maybe that was too much. Let's look from the 20th, the direction. Yeah, I want to take this up until I start to see these values. I don't like these, so let's try the 22nd. And a little bit earlier than that, let's just call the 20th. I'm being, well, conservative, and if this is set up to write out, yeah, it is, and we can just have a quick look at this whole batch. That these are, here we record the adjustments. So these are all the adjustments for NEAM. I want to just delete this folder and run this again to be sure that the adjustments that are being now automatically dumped into this folder are the final ones. Yes, because I had some before that were, say, obsolete. So you can see with this filter, we've dropped 18 hours of data. With this burial of relative humidity 1, we're dropping up to 2093 values, etc. These can be concatenated and fed back into the main branch of the GC-Net data filtering. It just dumps out these. I think I'm done. I hope I'm done. I've done this filtering on 3, 4, 5, 6, 7, 8 of the VSL GC-Net sites. The plots and data are stored in this GC-Net VSL folder. Here are the data frames. Here's DI2. Here's Humboldt, etc. Figures, DI2, quick look. Pressure is really too high. It's still fluctuating, but I dropped it because it just it needs more attention. And but some really good news, since we actually visited and re-leveled and reinstalled this station, I think we have quite a nice temperature series from DI2. Relative humidity, perhaps. I don't know what's going on here, to be honest. Um, Wind speed, wind direction. Yeah, that's a pity the pressure is not acceptable. If I just have a quick look at that, or look at it once again, die2 pressure, actually started out with some outliers. If I turn it off, this nanning of the pressure, just we can have a quick look at, that was neem. I need to set this to run on die2. Here we go, dy2. So here's the pressure. Something's not right with this barometer. And then even if it was, these are air pressure minus 1,000. These values were simply too high. And there's some other strange artifacts in the data. So that's why I chose to drop the pressure, which is sad because the data assimilation, it likes the pressure when the pressure is working. So I'm going to go back and turn that back on. I just hit undo now. Die2, the uncomment this guy, run it again. And I've done this filtering effort on also the PROMICE stations, including the PROMICE GC-Net stations. I actually need to run that. I can do that now. I believe that it's kind of good to go on that. So I just say if network is equal to G for Geos, the GC-Net Geos stations, I run that. That would be on all of the stations. So now you're going to see, for example, here's NASA U coming into play, and we can just look at the figures, which are, of course, easier to look at. NASA U data, for example, looks like this. And this is typical. There are a lot fewer outliers. You can see the battery dropping down below the critical value. That's why we have this gap. Let's have a look at another station. I don't know, Nuke K, Nuke L. These I'm actually estimating the elevation hourly using this fit to the data. And so Nuke L is on ice, apparently that's thinning. It's not surprising to see this. We have something like, what is it, 9 meters of average thinning in more than 6 months. And a lot of these sites have this, like here's Cass-L, looks like it's 5 meters of thinning. Yeah, JAR, we only have data early on. That thickening trend is obviously spurious. But it's not a huge change. We're talking about like a meter or less, so we can live with that. East grip, I haven't looked at this. Yeah, it also has a spurious thickening trend, or maybe it's real, but it's not a huge trend. What's interesting is that we have hourly elevation estimates. Crawford Point, yeah, maybe that site is thinned by 5 meters. That's what the elevation data from CP1, the Gaius site, looks like. Yeah, I've been over these data enough now that I think that I'm ready to go ahead and do a git push on this site. And when I do so, then Bjarne at DMI can gather the data. So I have in my repository something I call lazy push. If I cat lazy push, you can see that it just has the commands git add plus git commit. I pass it a phrase and git push all. So I'm going to say /lazy push. I'm going to say, gee, this is actually Kara timely updates, data delivery. for June 1st, 2021 to the 31 March 2022. And I run that. It did quite a lot there. I've been banging around in that folder, but it's in a much better systematic uh, shape. Okay, it pushed that to GitHub, and let's go on to GitHub and see what that looks like. Here's the repository. I've actually got some decent notes here. The work here is about delivering each month or so Greenland hourly AWS data with an emphasis on air pressure into the operational weather modeling system under Kara. The main, yeah, okay. If I go, yeah, into this, we can see that I've done all of this. Yeah, raw NVDAT data, that's the transmitted. Metadata includes all of these adjustments. There are many. These are focused on the NVDAT VSL data because they're just a lot noisier. I actually haven't applied this outputting of the adjustments to metadata yet for the PROMICE stations, partly because I assume that that's happening in parallel elsewhere. So I don't want to spend a lot of time on that. But now I'm in great shape. I'm actually gonna copy this a link to this repository and message to Bjarne at DMI, hey, have a look at these and let me know if you find any issues. I am starting to stack up issues in this repo. There are some residual issues like the Humboldt pressure is still noisy. I haven't just thrown it out. It's just noisy. Yeah, this update annual with logger data after field visits, that is what I referred to earlier as the quality control step 2. So far, we're at quality control step 1 with this Kara data delivery. Yeah, this older data for Kara 2, this goes back to the beginning of all of these weather stations because there's this Kara 2 project that's happening later. Yeah, so interesting stuff. It's satisfying to get it to this level of data filtering so that we can get it assimilated into the Kara reanalysis. Thanks for watching.